Okay, top of the hour again. All of those just joined us. Good morning, good afternoon, good evening, wherever you might be. Thank you so much for making the time to join us today for this TBC Power Hour, Automatic Ground Control Detection for Aerial Photogrammetry. We're really glad to see you joining us today. I see a few people are still jumping on, so let's give it another minute, I think. Looks like the numbers are slowly but surely stabilizing. I think we can get going. So let's get going on this. Again, thank you so much for your time. We appreciate it. Today will be an interesting topic. I know there was a lot of questions when we released version 2025.10 about the automatic ground control detection. And hopefully with today's session, you will get all the answers that you need on how this works. And I'm sure Tom will be glad to share this with you. Next slide, please, Tom. Just a quick introduction. Myself, Albert Willifie, Technical Product Manager. Been around Trimble for over 3 years now. And joining me today is Thomas Widmer, Senior Product Manager looking after the aerial photogrammetry. Tom, introduce yourself.
Yeah, I'm mainly doing photogrammetry since I'm born as a child. No, I mean, studied in Stuttgart and then located in Stuttgart in Germany, and then also did my master's in Canada, in New Brunswick, and being long time consultant support and training for photogrammetric software, and then product manager since 2023.
Thank you so much, Tom. Just a quick few housekeeping items, and then we'll get into the table of contents. If you have any questions, please make sure you use the Q&A section. You'll see down in your control bar, there should be a Q&A option. The chat, we don't use that for any questions because the Q&A actually gets recorded and we can reach out to you afterwards. If we don't get around to all the questions, and I'm pretty sure we'll have quite a few, so please make sure you use the Q&A section. The chat section is not so great for answering questions when it comes to any of this. Other than that, the recording will be available within the next few days. You'll get an email to notify you when that is up into the YouTube channel. So we are changing our recordings into our YouTube channel going forward. So you'll be able to find the recording over there. With that, I think that's all the Q&A stuff, the housekeeping stuff I had. We'll get to the Q&A when Tom is done with his slides. So thanks, Tom. Appreciate you can take over and take us through the Power Hour. Thank you.
Thanks, Albert. So hope that we can cover all the questions and also go into the topic. So why, what, and how. So let's start. Why? There are some obvious things, but also some interesting things. I hope that this helps you also to understand. So first of all, running an automatic control point detection, so the parts, allows us, of course, to accelerate the process. So automatic detection and measurement of ground control points significantly reduces the manual work. So if you have your drone flight and you see the control point in 50 images, then hopefully the automation will find it in all the 50 images and you don't have to click them in this case here. So therefore, for us, it's about 5 to 8 times faster than the manual measurement, and it's automatic. You don't have to do it yourself. So therefore, shortening the time and getting faster to your result. Another thing that is also nice is the automation tries, in this case here, to remove human errors. Also fatigue, it's a very boring job measuring control points, and also to avoid subjective interpretation. I will try a little bit to go into this part. Secondly, also it's a consistent algorithm. That means it always uses, in this case here, image processing techniques. And very interesting also to take into account, it's a little bit even accurater than a human observer can measure. If you have a good signalized control point, we will see there is also potential to have not so good control points, but the measurement is typically within 1/5 of a pixel. The human is doing typically a visual estimation where the center of our control point is. So we typically can measure about 1/3 pixel accurate, and the computer vision system is reaching around 1/5 of a pixel. It means you can better run the geometric georeference of your project and therefore get a better result, which consists in a better point cloud, a more accurate point cloud, less noise in the point cloud, and therefore also the orthophoto should then be of better quality. Then also there is consistency and repeatability. Consistency is, I think, also a very interesting thing. So you don't have to, in a manual way, you always zoom in to measure your control point. And if you don't zoom far enough, then you measure on a lower pyramid level or on a lower resolution level. This is, in this case, from the automation automatically taken into account. We always measure the control point on the highest resolution. And repeatability, that means in this case, if you rerun the project a second or a third time, then you would always get consistent same runs. Also, when you measure a control point, which is funny, but that's how the human being is, people differently define what is the center. So if I would measure a control point and Albert would measure a control point, we would not always agree that this is really from our estimation or interpretation, the center of a specific pixel row or intensity of pixels where we think that they cross each other. So this is really here what the repeatability and consistency is nice about automation, if it works in this case here. Okay, so this is about why we want to do this, mainly, of course, to avoid this boring job. But what are we doing? In the end, what we are offering is in TBC to automatically detect checkerboards. And checkerboards can be of different types. It can be really the classic checkerboard. I learned now the second one is called a bow tie. So I'm not so much a tie person, but in this case, a bow tie. And then, of course, it can also be a variation of the checkerboard. For example, some people have a circle, but in the end, it's a checkerboard. So if it's just cut off with a circle, this doesn't matter. Therefore, this is something that you can then use for the automation. Then another thing or here a couple examples just to make it, in this case here, also with some image content. So what you need to consider is that your target has a specific size. And size always in image algorithms is always in relation to your ground sample distance. So that means if you fly with 2 centimeter ground sample distance, this means in my case here, the target in the center would be 25 times 2 centimeters. So this target would be 50 by 50 centimeter of size. This is what we would recommend of a size. So this target should be of this size in this case. It also can run up to 15 by 15 times. And you see, this is why the checkerboard is a nice target, and that's why we also picked it as the first one. It is very consistent, even if you go in a very low resolution. In the end, we can still estimate, and that's where I would now say where Albert and I would perhaps not agree. Where is the center here on the right side? Is it where this gray pixel ends here, or is it somewhere in the center of here, or is it the left side? So this is where interpretation of the human being comes in. For the computer, it's very simple. It uses here a gray intensity value on these sides and just calculates a Gaussian calculation and defines this is the center. Just for showing how this can, if you would have not crossed checkboards, this is not supported. Please, in this case here, I just want to show this is where now when you have different types of targets, where this can really become more and more difficult. Now you can have difficulty also to find, in this case here, what is the number of this target. So it starts to differentiate. Is it now a 2 or is it a reversed 7 or is it a 5? Difficult to say. Also, you see that the target center is now very much estimation on our side. So here it's much better, but here it really then would get lost. That's why in general, in the future also, when we target other targets, we would probably stick with the recommendation of 25 by 25 pixel sizes or ground sample distances for our target. Another thing that you also need to take into consideration is that your targets should be placed at least of a distance of 10 meters. I will show also why this is the reason in this case here. But therefore, if you have multiple targets, then they should not be too close to each other, because then we have a specific search radius that we are allowed to search for the target, and therefore this can come to misinterpretation or misselection, and therefore I have here just shown here, this is my target, and then the red circle would mean inside this red circle, which is 10 meters, there should not be another one. So these two are, I faked them with Photoshop. Please be friendly to me. There was nobody who did this, but just to make it clear, this should not be the case. They should not be within this range. Then another requirement is, I mean, makes totally sense, and we see also why. The image quality has to be good. So that means if you have image blurring, or sometimes also there's then through the blurring, there's also these slide effects in your targets, then of course it's also more difficult to measure exactly the center of the target. Also, you should not have low contrast image, or also your target should not be low contrast. So for example, here I have an example. This was, somebody was using a nice green color, green and white. Unfortunately, it was both reflecting, and so it's really difficult now here, even if it's a checkerboard, to determine where is now here the center of the target. So therefore, please, we would recommend try to use black and white targets, or targets that have very good contrast between these colors. The algorithm is working mainly only on RGB, so even if you would now have here additional other layers, then this would not be taken into consideration. So also, for example, coded targets at the moment we are not supporting. Then of course, your GCPs are in TBC, so they must be having projected coordinate system. And you should have your images, which is also a TBC mandatory, should have at least GPS positions. And therefore, these images with lower accuracy are typically around 5 to 10 meter. And also for the high precision GNSS, of course, this is much better. I have two examples where we can see both of these options. Another thing is also that our algorithm, in this case, mainly here is trained to work on nadir images or slightly oblique images below 30 degrees. Here, these examples have here extreme angles of over 65 degrees. It's not that it will not, that we will prohibit it, but the failure rate in this case increases more. So sometimes it could still work, but again, our algorithm was mainly trained here with images of nadir and slight oblique images. Then, did I have everything covered? Exactly. So these are then the requirements. And Albert, feel also free when I missed something out, just interfere. Okay, so this is then what we are automatically detecting, and then how are we doing it? In the end, what we are doing is a semi approach. So in our case, or let's perhaps here start with the basics. So this is an example of an image, and then the target, our ground control point target, is a very small part of this whole image. Yeah, so an image with 3000 by 4000 or with 14,000 by 8,000 pixels. In the end, we remember we just said 25 by 25 pixel, so it's a very, very small portion. So what we are doing is we offer the automatic ground control point extraction after the relative adjustment, or in TBC, this would be adjust photo stations. Yeah, so not adjust photo stations with GCP, but adjust photo stations. This is then a relative adjustment. Of course, if you have already high precision GNSS, there's even a little bit more involved in it. But this includes also already If it's a relative adjustment, then there's a simplified camera calibration already included, which is good because then we can avoid the distortions of the lens. And if we already have high precision GNSS, then we would even include already focal length correction, which is again helping us then to better pre-position our starting point. That means we are then we have now relative adjustment or absolute adjustment, and therefore we can already know that our ground control point that we search should be in a specific area. And that's why we then will not search through the whole image, but we will search on a section. I symbolized it. It's not a circle, but this circle here is symbolizing that we don't search on the whole thing, but only in this area. And therefore, this allows us to be faster. It is typically, because the relative adjustment, when it succeeds, then we are in this range. So we are very generous. We are searching in a larger area than we should be. But in this case here, this is where it starts. And after we have now this area, then we are searching this area and we are doing an object detection. So these are, for example, here's some examples here on the top right, lower right, and lower left. So we automatically detect this target. Then this target, in this case, is then cut out of the search area even further, and then we do a center detection. Then we say, okay, in this target, this is now where the image matching takes part. Sorry, not the image matching. This is still, in this case, a center detection, sorry. And then with the center detection, we refine it then with an image matching afterwards. So therefore, we are reaching, if the target is good and not distorted and not blurred and not low intensity, then we are reaching here this a 5th pixel accuracy is potentially possible in this case here. Okay, so far then about how we do it, and therefore I want now to show a workflow. I recorded a video just always it makes it easier for me to talk on the side of it and also to stop it and then always then make it again available. So let's take a look into TBC. Let me here just stop it first and make it large on the whole screen. And then we can here take a more detailed look. So in TBC, the automatic ground control point detection is part of the adjust photo stations. Yeah, so after we have run the adjust photo stations itself, this is what I just mentioned with the relative adjustment or relative with absolute adjustment. Then we can start the adjust photo stations with GCPs. And then when we go to the part, we can select the absolute adjustment. And then we can add the control points from our Project Explorer. So therefore, we will now add these points that we want to run automatically. And we will add them to our control point list here on the right side. And all the control points that we list to the right side, they will all be executed in full manner in this case here. So that means if you only want to measure 3 or 4 of them, let me here perhaps just make a short stop here. Let me bring it back here one more time. Then we only bring these 3 or 4 control points first, then hit the automatic part, and then afterwards we can manually measure the other ones if this is necessary or needed. I assume everybody wants always to measure all of them. So in our case here, our data here is a high precision drone. So that means we have GNSS data that is 2 to 5 centimeter accurate. That means when we did run the adjust photo stations, then we already are here calculating with high precision. And now the prediction, we see this white triangle here. I hope you can see it in this case here. Let me here zoom in one more time. Unfortunately, not so good. White on white is not so good to see. But there's, in this case here, this white triangle. This is not my measurement. This is now my prediction, which is nice. So that means with high precision GNSS, we are already very close to the right position. And again, about the search area we talked before, this is typically with the high precision GNSS never a problem or a case. Again, this is done, would be here our center point, and then around this with enough area, we are taking this whole cut area and automatically search in this image here for this control point. For now, it sounds a little bit strange. Why do we search for such a big area? Why we don't just take here the center point and around? I will show this in later on a slide when we have not high precision GNSS. Yeah, but in our case here, we don't know it, so it will search this whole section here around it and try to automatically detect this point. What we here in this video just add, we add all the other control points here on top, and then we can then automatically run the automatic target detection, which is here below the list. So we can see here's the run automatic target detection. One thing is also possible, you can do it before or after. Your control points can be either control points or checkpoints, or you can disable them. Yeah, so this is as normal as you work with TBC. You will see then here the option. You don't have to do it before, because now it's only doing the measurements or the observations. And then before you hit on the bottom the adjust button, then you have then to change this part. Yeah, but in our case here, I did it now in before. I could have done it also afterwards. Yeah, so this is part. And then it will always run all the control points, as I mentioned here, from this list. And then we will just a little bit here in this video fast forward to run here this process. The extraction in this case here will flag our points with automation. So that means we definitely will always be aware which measurements have been done manually by myself and which measurements have been done from the automatic algorithm. Yeah, so this is something we will also take a look here in this video, where we can then differentiate always between these two different types of measurements. So in my case here, we have these 1, 2, 3, 4, 5 control points, and these control points are flown with an 85 by 85% overlap data. So we see here we have measurements up to 29 measurements in the whole project for one point. Let me here again quickly stop this here. So for our point 6001A, we can see here that it was measured 8 times. So 1, 2, 3, 4, 5, 6, 7, and 8. And these 8 measurements are auto. I'm not German, I don't know, auto. We have a car, no, automation. So auto, and then we will see then later in the video, I will measure a manual point, and then the mode will display manual, in this case here for this part. And of course, I can always on top measure manually. Either the measurements that have not been measured at the moment here. Let me also show here one more time here to stop. This was nice in this video. Let me here go a second back. Unfortunately, I don't see here, don't see the triangle again here. It's difficult. I hope I will show it. But there's the triangles here on top. This is the predicted position. For us, the important thing is this yellow dot. So the yellow dot is our measurement. So this is the observation. This is the one that counts. And therefore, this is then also a quality check that we can do. So that means after you did run the full automatic detection, you can, if you want, I mean, most people won't do it, but it's possible in TBC to review the measurements. So because this is the observation that we see here. Here I see now the triangle. Yeah, that's what I tried. So you see here, this is the triangle. This is the prediction where it assumed where the position is. And then the yellow one is our observation, our measurement. Then you can, of course, also delete measurements if they don't make sense. Perhaps your image is corrupted or not valuable, or in this case, as in this video I try to show here, is also to manually measure. You can still go in and you see why it failed. I mean, this is very oversaturated or overexposed, so it's really difficult here to measure it. I still measure it here in this video because I want just to show that it's possible. So we can then go here in, and then as in TBC, standard-wise, you click on it, you get the magnificator, and then you measure in the magnificator your point, and then this becomes this one measurement in this one photo for control point 6001. And you can see, well, I was doing a nice video, but you can see it here. It's called manual in this case here. Okay, so this is then how you can execute the ground control point measurement here in TBC photogrammetry. Also, when you, and as I mentioned, so this is now the measurements, and of course now we need to execute it also. This is now only the what you have done manually, and then you click here on the bottom, and then you adjust it, which is then a post process. Yeah, so it's not rerunning the type point extraction. This is now here taking these measurements with the previous existing type point extractions, and then you run an absolute adjustment, including now the ground control points also with their status. So in my case, I have now changed one to checkpoint. This one stays a checkpoint and will not influence our adjustment, but the others that are control points and enabled, they will influence. And let me also perhaps stop here because then perhaps something will come. From the weighting system, we are keeping it in the same. So that means if you measured it manually or if you measured it automatically, we do not at the moment change the weighting. So that means that I give my manual measurement a higher weighting or the automatic one a higher weighting. Because you remember I explained at the beginning, automation has the potential to measure up to 1/5 of a pixel, and manual measurement typically only 1/3. But because there's also then the option that you have still sometimes for these low textured targets, the human is still smarter, which is good for us all here, then we still keep them in the same weighting system. And then when we did the adjustment, then you can just take a look at the adjustment report. You have your ground control point statistics and your checkpoint statistics, and then they are just listed as we are known to it. This is nothing different than we have done before. The only thing is I did not have to measure 26 times manually something or 22 times something manually. This was now fully automatically extracted. And the question that always comes, I'm not sure, is how many should I measure? And then I always give the same question answer. From a photogrammetric aspect, you want to measure all. From a practical advice, I think then this for automatic, if you reach this high automatic measurements, this should be already enough. The thumb rule is always this: if you fly with 80% overlap, then and you fly typically in strips, that means within one strip you have 4 images that can overlap. So you should at least have perhaps 6 measurements, because 2 of the measurements have to come from a different strip. So 4 can come from one strip, and then if you have 6 measurements, then the other 2 have to come from somewhere else, and therefore they come from the neighboring strips. And this is what we want, because this gives us more redundancy, more stability. So this would be a very good thumb rule. I would still prefer to have many more, because you have then more redundancy, which allows us also to kick out wrong measurements. Yeah, so if for some case images have a problem, then this one measurement from this image does not need to be taken into account. Okay, so far about this here. And let me here also cover then the other case, yeah, because now my project that I showed here in this video was a high precision GNSS dataset, but what if my data is not having a high precision GNSS? So if you have a low GNSS quality, then typically the GNSS or the GPS positional error is around 5 to 10 meter. Typically, it's not anymore so high, it's lower, but there's a potential that this can be also only 5 to 10 meter accurate. This is totally okay for navigation, so flying a drone, bringing the drone back to where you started it, this is totally okay. But of course, for mapping purposes and for surveying, creating accurate maps, this is not sufficient. That's why, of course, we also need then the ground control points. Having now a lower accuracy in your GNSS will also cause that your pre-position of your image of your GCP positions will not be pinpointed on the target. I hear extruded here the positions. They are normally smaller things, but you don't see them. That means this is my real target, and after I did run the relative adjustment, then my target here in my part, I can scroll up this statistics. I had about 1.5 meter to 2.5 meter positional accuracy for my GNSS in my my relative adjustment, and that means in this range, typically with 2 to 3 sigma, somewhere around my target, my control point will be pre-positioned. So that means, in my case, top left, he thinks after the relative adjustment that my GCP is here, which is not correct. It is here, and that's why we have to search in this area around here to find the target. This is also depending if you have if the target is almost in the center of your image and you look straight down, then even if we have a positional error, it will still stick very close to it. So therefore, it can be closer, but it can also be further away from our real position. And then the algorithm has to do still the same parts. It searches the area, it finds the control point, then it makes this object detection, as we said, then the center detection, and then it measures the center of our target. One more thing, perhaps, again, as we have the slide deck here, and you can review the video if you want later on for yourself. So one more time, so you can always, before or after, define for each control point if this is enabled as a control point. So if the status is enabled, it's a control point. This point will influence your adjustment. It will influence your camera calibration. It will influence, in this case here, then also, and have an influence on your point cloud position and also your georeferencing. Then if you do it as a check, then it's a checkpoint. This will not influence, in this case here, our orientation, but it gives us a very good indication how good our results fit to this checkpoint. Checkpoints are always, like we say, the absolute method to check how good our orientation or our drone processing has been executed. So typically you place always your checkpoints in the area of your interest. If your area of interest is a stockpile, then you put it close to your stockpile. If you do road construction, then you put it on the road and perhaps also on the slopes. So this is exactly what it is. I don't think you will disable it, but you can also disable if, for example, your colleague gave you the wrong coordinates, or you had a problem when you measured the control point and something went wrong. Of course, then you can also disable it. The mode includes auto and manual. One thing I missed to say also, if you measure manually and you would rerun the automation again, you can run it a second time and a third time. It will not change to, I will come to this also. But manual measurements will never be overwritten from automation. So if you measured something manually, it stays manually. If you go to Vegas it stays in Vegas. I don't know if this makes sense. But in the end, manually measurements are, in this case, you have done it, so it will not be overwritten by the automation. You could, for example, this is really old classic photogrammetry. If let's say you, for whatever reason, you have 30 control points or 100 control points for whatever reason, you could only measure 4 control points manually in the corners, then run the adjustment, then you have better pre-position, and then you could run for the remaining 96 the automation. Yeah, this is also a possibility. This was done in the old times in classic photogrammetry. It's possible. Yeah, so you can run the automation multiple times. In between, do manual measurements, add this part, and then rerun it again. In the end, the only thing that is different is better pre-positioning, because hopefully with your few manual measurements, you were able to adjust the data better. You have better positions of your drones, and then better pre-positioning, and then the automation has a better chance again to find the targets. So this is also possible, but normally this is not the goal. Our goal is in this case here that you can run it in one run with the automatic target detection. Then the next part in this case here is then the report. Nothing new. I just wanted, because we talk about ground control points, just to again take a part on it. So we have in this case here the standard deviations and the RMSE, which is the what is at the moment from the ASPIS positional accuracy standards, what is asked for. There was formerly also then the 95% confidential level. This was now again taken out of our protocoling as they asked for it in this case here. On top, we added now these RMS, E, H1 and V1 and 3D. In the end, the H1 is just the vector combination of your RMSE for X and Y. Yeah, so it's just because they want to have a positional vector and a vertical vector. And then also a spatial one is the RMSE 3D. In the end, this is really your RMSE here. So this one here is just then defining the below ones here in more detail. Then also from and the same thing is also then done from the checkpoints. So again, from the checkpoint part here, we then see again the RMSE values here listed. Just to have it again in this video here, RMS, so the checkpoints have not influenced our orientation. They just represent how accurate the position or how good the residuals are at this position of our checkpoint. Okay, so far about this part. There is, at the moment in the temp folders, we also store a summary of all the measurements as a TIFF image. You will not find it in your TBC project. In case this is something that you are interested in, then let me know and let me give some feedback if this would be of interest for you. At the moment, we are not putting this into your TBC project. This is in the TBC temp folder stored, where you have a big TIFF file where you see all the measurements in one big image. If this is something that makes sense, that you think that this will help you to provide the data to your customers in a good way, then definitely something that I would love to hear from you as a feedback. Or if you think if we would change this a little bit differently, that would make more sense. Here I am, very open about this part. Okay, and therefore I went through the topics. I hope that I did not run too fast through it. But this is where I would now open up the Q&A. Of course, also we can go to some questions and go into detail into something else. Albert, feel free to take over from your side.
Thanks, Tom. I'll call out the questions and then you can answer them. first one from Navid, I think that I can even answer. No, you don't have to define the type of ground control point you have. So if it's a bow tie, if it's a checkerboard or whatever, those ones that Tom showed that we can detect, TBC will look for any of those types. You don't have to define it beforehand. It will automatically detect whatever ones you have that was shown as the ones that we currently have listed. So that's the easy one. Then, of course, the big question, Tom, always that we get from Christopher is L2 processing for LiDAR sensors. Is they coming to TBC? I'm going to leave
okay.
that one for you.
I don't know, to be honest, in this case here. Of course, this is a topic that we are much aware that this is a hot topic. So it's not that we are surprised. It's not that we have not, in this case here, covered the topic. But from my personal side, I'm not involved at the moment into the implementation. So for the next version. So from my side, I have to say I don't know it, Christopher.
What I can add there, Tom, if you do have a point cloud from a L2, which isn't georeferenced, there is tools in the TBC point cloud module to actually georeference a point cloud.
Yes.
So if you do have control values and you can see the targets or the, whatever you've decided to use as a ground control point in the point cloud, you will be able to georeference that point cloud if you import the LAS file into TBC. So TBC has the tools to georeference a point cloud after it's been processed in Terra, but it's not georeferenced.
Exactly. Point cloud to an existing georeferenced point cloud is possible in TBC.
Good.
And I have seen it already, somebody doing it, of course. What you don't do it in this case here is then adjusting also in this case. Here it's a pure transformation in this case, as I understood. Is this correct, Albert?
Yeah. Yes, it's a transformation. Yes. Good. Next one from Christopher. Is it recommended to use as many photos as possible? I thought that the recommended was not to use more than 9 photos. So you can delve a little bit more into what does the photogrammetry guys say? Do you use as many photos as possible or only 9 and not more?
You try to use as many as possible if you can measure it automatically. It's very simple in the end because especially, well, not especially, but it makes totally sense if you have not a high precision GNSS drone. That means that everything is bound to your control points. And wow, this goes now deep into it, but we can assume that typically you will not get for every image an equal distribution of your tie points. So if you, whoever has the question, ask me, think about one image where you have a lake inside your image. So that means wherever your lake is, there are no tie points there. That means you will not have relative information how this image relates to your neighborhood. But if there would be a control point in this image, you can at least bind this control point measurement as part of this image to your orientation. And then your orientation of the image will become better, which means even if you don't have tie points and your image becomes here less well defined, it will still cause to lesser errors in your orthophoto. Point cloud you will not create because on water you don't get points correctly, but the orthophoto production is still using in the classic method the orientation. And also for the 3D meshing, so also for this part, it should include because it looks better in the right direction for this image. So therefore, the more measurements of the control point you include, the better it is. And as I mentioned also, this allows us also to eliminate our measurements. So that means if I have a redundancy of, let's say, 20 measurements, then I can much better evaluate which of the 20 measurements are the best ones and which one is a stupid measurement that jumps out of it, is not part of it in this case. You can easier detect the stupid ones. And therefore, yes, please have as many as possible.
Thanks, Tom. Next one from Christian. Is there an integrity check outlier detection for auto as well as manual GPS GCP detection observations within the overall processing? In other words, do you have a way to see which ones are outliers, or do you have to manually go do it?
I just explained it, and this is exactly also what happens. What we are not doing on the TBC side and on US Master at the moment is listing them, because this is really tough photogrammetric internal stuff. There are files in the temp folder. So if you want to dig really deep into photogrammetry, there is even a log file that shows which ones have been eliminated. We don't eliminate the complete point. We only first eliminate single observations of this point. But then if we cannot keep the control point in itself, then the control point itself will also not be used into it. But we left this out here on TBC and US Master just to keep it simple from our side.
Thanks, Tom. Christopher said the TIFF file would be great for QA/QC standpoint. The TIFF files for the measurements that you've shown that we don't see at the moment. So there is one of the guys recommending that is a great QA/QC option.
Okay.
Henry Mark has asked, is this automated process is executed on the GPU, RAM, or CPU, RAM, or GPU component of your PC? So what do we use when we do the auto detection? Does TBC use the CPU, RAM, or GPU component?
At the moment, this is CPU. It could be also enabled for GPU, but at the moment CPU, because of course, I mean, if you count 1 and 2 and 3, there would be in the future, it would be not stupid to have a cloud solution that can use this in an automatic way. And if you have a cloud solution in the future, then you still need to get machines in the cloud, and not all cloud machines are always GPU capable or are more expensive. So therefore, at the moment, it's CPU. If we see that this really would drastically increase the speed, then GPU would be to consider, to think about, but not at the moment.
Okay. James is asking, will it detect painted chevrons? Or will it only be those?
It will not detect painted chevrons. It's really, at the moment, purely on checkerboards. Again, because if you scale a checkerboard stronger, it still is good to detect. So it has a very high potential to be correctly detected in comparison to a chevron, because a chevron has 2 lines, and it means the lower the resolution is, the less you see a line, and then it will become all of a sudden just dots.
Okay. And the same then for Daniel asking for round and cross-coded. So guys, the ones that Tom showed in the beginning, those checkered boards are the ones that we are currently using, because of, as you saw, when the resolution goes down, you can still detect the center of that target much easier.
I would have a question, whoever talked about the coded targets. I tried a little bit to dig deeper into it, and coded targets live from a specific pattern. And these patterns, of course, have smaller signals on it, in this case here. So whoever asked this, please feel free to, whenever you contact me or see me, would love to talk a little bit more about it. I see that this is mostly more used for smaller scale, so when the drone is flying much closer, so below 30-meter distance to the object. Definitely something I would also try to get also into discussion with.
Okay. Jacob also asking about additional GCP targets, chevrons, etc. I think we just talked about it. Checkered boards is the one that we use at the moment, and that is the preferred type. I'm sure Tom is looking into other types, but it obviously will depend on the quality of the detection that we can get on any other target types. So obviously we want to make sure you get the best result possible, and that is why the checkered board is the recommended one and the one that we are using currently. What's the main advantage of GPC? Okay, so now Caleb is asking a little bit more technical in here. What's the main advantage of using Trimble's program over a different one such as DJI Terra? Tom, is there any difference in the two? What would you recommend when it comes to One thing I can add to Caleb's question before we go further, obviously DJI Terra, you get a result as a LAS file, and then you've got to go into another software to do stuff with the point cloud. I know they are expanding that as well. But one of the advantages of TBC is you can obviously do a lot more with the data once it is in that format. Any other things that you can add there between TBC and Terra?
No, I would also say the advantage is really the easier combination of existing Trimble projects that you already have. This is really nicely integrated in it. You can run the baseline processing also in before. I didn't cover this part, which is really a nice thing that you can easily then also use, and therefore then reduce the amount of control points that you would need for your projects.
Same one here from Jacob, talking about Pix4D and switching over to TBC. Why TBC is a better program to use? Look, from my perspective is in TBC, you got a lot more additional functionality that you can utilize. So if you have survey data, if you have total station data, if you want to bring in your scanner data from terrestrial scanners and you want to combine all that into TBC and make sure they're all in a specific coordinate system and everything matches onto the same control, that's where the strength in TBC lies. It doesn't matter where your data comes from. You can combine multiple data sets into one single project and everything will tie into each other. You can process, as Tom said, baseline data. You can process your GNSS data. You can process total station, photogrammetry, scanning. Anything can be done in there and you can all match it up and make sure everything fits nicely into TBC. And the coordinate system is very options and functionality in TBC is very robust. So it makes it much easier to make sure that all your data ties into each other in that specific system that you're working. So you want to know the benefits about TBC, that is where I would go. Yes, Tom.
And as you mentioned, it's a modular approach. So you can start with TBC photogrammetry. You can easily then add the module of going towards, in this case, into feature extraction or going into, in this case, to point cloud extraction, in this case here. So this is really also then easy for you to scale from your pricing, whatever you want then to continue for. So this makes it really also simple.
Good. David just mentioning the .log files mentioned by Tom is important for customers providing photogrammetry projects to some agencies such as DOTs. They continue to require a detailed report for the photogrammetry adjustment results. Thanks, David. So the log files are important in that way as well. So if you are working with government agencies as DOTs, those kind of log files will be important as well for your proof of your adjustments that you've done.
Part of our webinar chat, Albert, can I see later on who wrote this and contact the person?
Yeah, you can definitely contact. It will be in the Excel sheet that we get from all the Q&A stuff, Tom. In what specific, from Christopher, ways could photogrammetry model use interface incorporation, adaptive machine learning driven interfaces such as reinforced learning for personalized workflow shortcuts, predictive tasks? Yes, Christopher, you're going into deep learning and AI. That is something we are actively looking into to see how that can benefit TBC. We are already using deep learning for a lot of our feature extraction, point cloud classification stuff. The algorithm Tom talked about for auto detection, that's also deep learning that gets involved in there. So a lot of the stuff in TBC is already using that. You don't see it because it's all done in the back end. You get the results. A lot of the results when it comes to point clouds and photogrammetry is driven by machine learning and AI that we utilize to get there. Yes, we are looking into bringing more of that into TBC. So it's on the roadmap. I know everybody is on about the AI hype and what can be done. Be aware that we are looking into that as well. We are looking in cloud processing machines, all that kind of stuff. So keep an eye out. We will be sharing more details as we go into the next 2 or 3 years with this. It is a process that we are involved in, so we will give you some updates as we go along.
I perhaps add from my side also, yes. Christoph, we still, from my side, that's my personal opinion in this case here, I still go more the classical way. So automation for me should reach 90% or higher, in this case here, to be effective. So that means when we are involving to get here this high precision with AI, this would be for me always at least something that I want to counter predict. For example, the ground control point measurement, we don't reach the 90%. We are here below it from the statistics that we reached here, we were around 86%. This is due, of course, then, as we showed here in these images, sometimes the image quality was bad, sometimes the targets were not well defined, sometimes they are hidden under trees or not visible in this case here. But I would, in general, perhaps as a comment more here, still try to go this way. AI should help me to automate and not make me go back and then try to find out again what did he wrong. But that's my personal opinion.
Yeah. Okay. Thanks, Tom. I think we are running out of time. So there is a few more questions, but we'll get them in the report and we'll reach out to you guys on that. If you want to add a few more, please add some more questions there. We will reach out to you afterwards. Tom, if you can go on to the next slide for resources. There we go. Resources, where to find all the stuff. First of all, the help, very good. If you have any questions about how a specific command works, if you open up the command in TBC and you press F1, it will automatically open up the help section for that specific command. So please use that on a regular basis. That helps a lot. Tutorials and e-learning. I see a question about how do we test out this automatic detection and can we get demo licenses and stuff? Yes, there is a free 30-day software subscription license that you can get to try out all these functionalities in TBC, but you can also go to the e-learn, which I will show now, and that will give you the functionality as well to look into. All the power hours are there. The YouTube channel is a great resource to find any of the stuff. One of you guys asked about the demo video that Tom showed. There is an auto detection demo video in the YouTube channel, so you can find all that. And as I mentioned, we are migrating all the power hours into that YouTube channel as well. So you'll have all the content in one space to find it. If you can go on to the next slide, please, Tom. There is learn.trimble. So if you go in there and you go look for TBC courses, we have 69 e-learning courses for TBC available there. They are all based off virtual machines. So it means you don't have to have TBC installed on your PC, nor do you need to have a full license of TBC. This virtual machine gives you access to the latest version of TBC and a license to all the modules that is available in TBC. There will be training data sets to work with, and you can then go test out any of the error photogrammetry stuff, the auto detection. There is a specific training course on that. Processing with or without trajectories, even 3D oblique imagery processing. If you fly around a tower, there's even that, how to do that in TBC, and all the other functionalities as well. So please jump onto learn.trimble and go have a look. Those virtual machines do help a lot. And as I said, you don't have to type a production license or a production PC or laptop for somebody to learn something for TBC. Utilize that. It's a great way. All they need is an internet connection and a web browser, and you're good to go, and you can learn TBC. That is everything that I have. Tom, the next slide is just a thank you to everyone. There you will find our email addresses. Just take note that between the names and surnames, there will be an underscore. So if you want to reach out and ask any questions or have any specific things that you think error photogrammetry needs to do a little bit better, please reach out to Tom and myself. We really appreciate the time. Thank you so much for joining us. And we will see you for the next Power Hour at the end of November. And just to give you a heads up, that will be showcasing the latest release that will be TBC 2025.20. We will then show you what is new in the latest release that will be out then. Tom, thank you so much for your time. I appreciate it. Thanks, everyone. And we will catch you again end of November.
Thank you.